Hello everyone, today we're going to be doing the second problem of the IMO 2019 and its solution. So the problem statement is as follows. We have a triangle ABC, points A1 and B1, which lie on sides BC and AC, and we let P and Q be points on segments AA1 and BB1, such that P and Q is parallel to AB. Now we let P1 be a point on line PB1, such that B1 lies strictly between P and P1, and angle PP1C equals angle BAC. Similarly, Q1 is on line QA1, again a similar conditions for this point, and the goal is to prove that points P, Q, P1 and Q1 are concyclic, which means they lie on the same circle. So I've already made the diagram over here with all the conditions. So first of all, we know that line AB is parallel to PQ, represented by these blue arrows. Angle BAC equals angle PP1C, which is this orange angle, and this green angle, and angle ABC equals angle QQ1C, which is this orange angle. So the first thing we do is make the circumcircle of triangle ABC, and we extend line BB1 to meet that at point E, and line AA1 to meet at point F. So now we start off by letting this angle over here be equal to Y, and this angle over here be equal to X. So now by the parallel lines, we know that this angle is also equal to Y, and this angle is also equal to X. So the first observation we make is that quadrilateral PQEF is cyclic. So the proof of this is very simple. We just notice that angle QPF equals 180 minus Y as a straight line over here, and again, and then we notice that angle QEF is subtended by arc BF, which means that it is equal to angle QAF, which is equal to Y. So now the two opposite angles in this quadrilateral sum to 180, which means that it's cyclic. So second thing we notice is that quadrilateral B1 P1 EC is cyclic as well. So to prove this, notice that angle B1 P1 C equals angle BAC by the problem statement, and since this is subtended by arc BC, this is also equal to angle B1 EC. So in this quadrilateral B1 P1 EC, we have this angle over here is equal to B1 P1 C, which means that it's cyclic because the two angles are subtended by arc B1C. So now we notice that we want to prove basically that PQ P1 E is cyclic. So to prove this, first of all, we find angle PQ B1, and this is equal to 180 minus X, since it's a straight line. And now we find if the quadrilateral is cyclic, then angle B1 P1 E should also be equal to 180 minus X, since the two angles are subtended by arc PE if it is cyclic. So to do that, we just divide angle B1 P1 E into two angles, angle B1 P1 C and angle E P1 C. So now this is equal to angle B1 P1 C is just equal to angle BAC. And now to do this, since we proved that quadrilateral B1 P1 EC cyclic, then angle EP1C should be equal to angle EB1C, the same segment again, and by opposite angles that's equal to angle AB1B. So this is equal to angle AB1B. So now we consider triangle AB1B. So we have the sum of the two angles, angle BAC, which is the same thing as a green angle, and angle AB1B, this angle over here. So that's just equal to 180 minus X, because the sum of the angles in a triangle is 180. So this is 180 minus X, and as desired, we have proved that the two angles are equal, which means that this is true. So now the next thing we do is we do the same type of thing for the other side of the quadrilateral. So we start off by proving that quadrilateral A1 Q1 FC is also cyclic, and to do this, again, angle A1 Q1 C equals angle ABC, and by the same segment we have that this is equal to angle A1 FC. So in this quadrilateral we have the orange angle is equal to the green angle, which means that the two that quadrilateral is cyclic. So now we want to prove, as we prove that PQ P1 is cyclic, we'll be looking to prove that FQ1 PQ is cyclic. This is point Q. So FQ1 PQ cyclic. So first of all, notice that angle A1 PQ is equal to 180 minus y. That's the straight line. So all you have to do is prove that angle FQ1 A1 is also equal to 180 minus y. Again, we divide it. So FQ1 A1 equals angle FQ1C plus angle A1 Q1C. So we divide it into this orange angle and this angle over here. So by the cyclic quadrilateral A1 Q1 FC, we know that FQ1C is just equal to FA1C, which by opposite angles is equal to AA1B, and A1 Q1C by the problem statement is just equal to angle ABC. So again, consider triangle ABA1. So we have the sum of the angles ABC, the orange angle, and AA1C, which is this angle, and that's clearly equal to 180 minus y. So now we have that FQ1 PQ is cyclic, and PQ P1 E is cyclic, and PQ EF is cyclic. So this just means that points P1 and Q1 also lie on the circle PQEF, which implies that points P, Q, P1, and Q1 are concyclic. So that's all for this problem.